are around mechanical engineering. And these products were sold on the basis of the mechanical engineering capabilities, right? So the same Bajaj Chetak scooter today looks very different, and the ad looks completely different. It looks like as if they are trying to sell a gizmo and not a scooter actually, you know. So that's how products have evolved and changed over a period of time. But the pace of innovation has accelerated since the pandemic has set in. And if you look at this, again, most of you would recognize this. The one on the left side is the cockpit of the XUV 500. The one in the middle is the XUV 700, which was launched right during the pandemic. And the one on the right side is the new electric platform that Mahindra just announced, which will be on the roads probably by 2024. You can see the way it has transformed. And the pace of innovation and acceleration is just unprecedented in the industry. With all of this, we thought it is only appropriate to call this conference with the theme of convergence of simulation, high-performance computing, and artificial intelligence, the three technologies that Altair brings to the market. Because without this convergence, development of such products wouldn't have been possible, and the pace at which these products are being developed would not have been possible. So we thought it is appropriate to have this theme, and a lot of the speakers in the subsequent presentations will talk about this convergence, and you will get to hear about this in many other places around this conference venue, right in the booths, the display areas. We have a couple of live product displays. Again, there you'll talk about some of this convergence. You'll see them in action, how some of these technologies are working together to create really innovative products. To dwell a lot more about this convergence and the area of digital transformation, we had a thought leadership event yesterday evening at this very same room. We had industry stalwarts from various industry domains, talking about how they are using digital technologies to create breakthrough innovations and innovate and solve some of their most challenging problems. So this year's Altair Technology Conference is being held at two different locations, in Bangalore today and tomorrow, and then we move to Pune on the 16th of September. And we started the ATC series way back in 2004, and since then conference has been growing in all possible ways, whether it is the number of papers being presented, the content itself, the number of people attending the conference, in all possible ways. So the growth of the conference is synonymous to the growth of Altair as a company. We've been growing at a very, very rapid pace. Our technology spectrum has grown tremendously. Just to mention, in the last 3 years, since the time we met in 2019, Altair has made 16 technology acquisitions. Many of these products are on showcase in the booths outside, and a lot of presentations would cover some of these technologies through the next 2 days. And we've also added a lot of new customers since the time we met in 2019. We've added close to 200 new customers. Okay, and this is probably I would say, the fastest in terms of acquisition of new customers. That is a very clear indication that we are able to add value to the industry, and a lot more customers are beginning to adopt our technologies. So these are all the new customers that we have added since 2019, and I would like to welcome all of them. I'm sure many of you are in the room, to the Altair family, and look forward to a very, very collaborative engagement as we move forward. Just a quick introduction to the keynote speakers for the conference. We have Lata Chamberkalam from Continental. We have Yogesh from Wabtec, Mr. Radhakrishna from LRD, Mr. Thangavelu from CSIR, and Mandar from TCS. These are the keynote speakers for Bangalore between today and tomorrow. And then in the Pune series of the conference, we have Mr. Anil Kumar from Tata Motors and Mr. Imran Mullah from Classic Legends. I would like to take this opportunity to welcome all of them to the Altair Technology Conference and thank them for their time. I would also like to welcome all our Altair global experts who have traveled from various parts of the world to be here to share their expertise and knowledge with all of you. We have close to about 100 papers being presented across various tracks, and then as it has been the tradition in the past, we get an external set of jury members to assess these papers and rate them and rank them and actually give them prizes. Okay, so we have a very, very diverse set of judges coming from many industries. As you can see, we have representation from automotive, from aerospace, e-mobility, consumer appliances, medical devices, government research, defense research, academia, and many other areas. So it's probably one of the most diverse set of judges that we have. I thank all the judges for taking their time out to sit through the paper presentation and assess and rank the papers. And also, as I mentioned, we have about 100 papers being presented between today and tomorrow. I thank all the paper presenters for making the experience enriching for our audience. So we have 10 technical workshops between today and tomorrow, and each of these workshops is followed by paper presentation on those specific domains. All the agendas are displayed outside each of the rooms, so you can look at the agenda and then you can decide which one of these tracks you want to attend. We also have 2 parallel conferences going on. We have an HPC parallel conference going on that starts at 2 p.m. People who are interested in understanding more about high performance computing, cloud computing, I would request them to attend the HPC conference. And added to that, Altair has been doing a lot of work with startups. We've been running Altair Startup Challenge for the last 4 years, and we've been mentoring a lot of startups, and we've been providing them assistance with our technology, consulting, and also helping them reach out to venture capitalists to seek funding. So there is a separate track which is running. It's called the Altair Startup Incubator Outreach that again starts at 2 p.m. And again, we have a very, very diverse set of speakers contributing to this initiative. People from ISC, IITs, incubation centers, startup founders, and our Altair team as well. So if anybody is interested to understand more about what we are doing for the startup ecosystem, please attend this track. So that's the last slide that I have. And I would like to now call upon Nelson Dias, Chief Revenue Officer of Altair, to talk about the convergence of simulation, HPC, and AI. Thank you, and have a good day. And I hope all of you enjoy your stint at the Altair Technology Conference and network and have a lot of fun. Thank you so much.
Good morning, everyone. Good to see again, like Vishwa said, a lot of familiar faces after 3 years, face to face. As a Chief Revenue Officer, I have to put this statement up in case I make any forward-looking statements. Like Vishwa alluded to it, we believe Altair is leading the convergence of computational science. When Altair began in 1985, we primarily focused on simulation replacing test, moving to bring simulation in front of design with simulation-driven design for conceptual design. In the early 2000s, we began investing in HPC as we saw the future of simulation requiring more sophisticated compute resources and the value of strong connection between the hardware and the software. Then in 2010, we dipped our toe into the data analytics field with applications primarily in the BI space. Seeing the convergence direction in the market was headed, we continued to invest in data analytics and AI, seeing the importance of AI on simulation. Today, to view this convergence of simulation, HPC, and DA all as computational science. Just some statistics about Altair as we stand today. We have about 86 offices in 25 countries, $532 million in revenue last year, 15,000 plus customers, 3,000 plus employees around the world, 150 software titles, plus the partner software titles. So the 15,000 customers worldwide, they have a significant breadth of verticals. As you see, we are very strong in manufacturing. Automotive is still the #1 vertical for us. The next 3, aero, financial services, technology, electronics. are about the same size. We also play in the life sciences, material, government and defense, civil engineering, and many others. So the portfolio has gone across many, many, many verticals. The three main segments that we focus on is physics simulation, conceptual design, HPC, and DA and AI. More and more we see the industry and our customers going in the direction of convergence and have the vision to do the same. Having seen each of these segments independently gives us a strong differentiation on the convergence of them together. Additionally, Altair has an open philosophy and we go to market with units that most of you are familiar with, which allow our customers the freedom and the flexibility to ensure they are using the best technology and products for their use. Vishwa talked about the pace of acquisitions. It's a very vigorous pace. Again, we continue to invest or acquire companies for their technology, not only market share. So it enriches the units that all of you consume. I'll talk about the last few ones that we have had over the last 4, 5, 6 months. World Programming is a UK-based technology company, specializes in data analytics software used by many of the world's leading companies, including financial services and insurance organizations. So this is the only other company that has a SAS language compiler besides SAS itself. S-Frame software is a structural analysis software platform used by engineers to evaluate the structure's ability to withstand external loads and meet the design code requirements around the world. Cassini, pretty much an acquisition in Hyderabad, India, is the next generation cloud-native technology for Industry 4.0. With this, Altair deepens his expertise and strengthens his ability to offer the digital thread solutions via the Altair One cloud platform. PowerSim is a market-leading provider of simulation and design tools for power electronics, including power supplies, motor drives, control systems, and microgrids. This really expands our electronic system design technology and, of course, in the domain of power electronics. Gen3D is a startup out of the University of Bath in UK and is a pioneer in implementing implicit geometry method for describing highly complex geometries such as lattice structures in additive layer manufacturing. The last one out here is Concept Engineering, is a leading provider of electronic system visualization software that accelerates development, manufacturing, and service of complex electrical and electronic systems. Here's a snapshot of a number of different articles showcasing different use cases and solutions across the many verticals, from accelerating design for verification of chips to building of the future, focus on sustainability in civil engineering. We're truly a technology company with great technical expertise that helps customers push the boundaries in many different industries. One such acquisition from last 3 years is SimSolid, that's making waves all over the world. Renault is really taking their designs to the next level with SimSolid. And I really couldn't say better than what Anthony has to say in terms of, to us, SimSolid means efficiency. We have a similar case from here in Pune, Tata Motors, using SimSolid, the best concept delivered at the start of the project. And of course, a lot of CEOs of the new age companies, of the born digital companies, of the born electric companies care about simulation much more than CEOs in the past. A good example is an interview that Royston had with the CEO of Lucid Motors.
Yeah. And do you see simulation? Obviously, my whole life has been around simulation. Do you see simulation being more part of that engineering collaboration as well? Is that piece in your armory?
Totally.
Yeah.
I've always been a huge proponent, and that's how we met and how we know each other, and the relationship with Altair. I'm a great proponent of simulation. I brought deep simulation to my previous company here in California, and how the hell have we wouldn't have been able to do the car behind. We would never, ever have made the breakthroughs. The breakthroughs we made with this car were breakthroughs on the computer. If you look at some of the electromagnetic efficiencies that we created, that was all computer simulation. And I'm also a great proponent of multi-physics, and the dream is to create one homogeneous model, a multi-physics model of the complete car.
Yeah.
You will hear more from Royston right after my presentation. Again, my colleague Michael Dumbach will talk more about the new user interface and the modeling products. Essentially, a consistent user experience, never leave the model, very AI-driven design explanation ingrained in your workflow. We have seen 10x gain in productivity and quality, ability to create and explore multiple design configurations, powerful multi-physics environment to design complex products. And we have a lot of early users of this user experience in the audience, JCB, John Deere, Alstom, so on and so forth. So please talk to them and understand their productivity benefits, or reach out to Michael Dumbach, who will be presenting later today. Like you saw in most of the slides, we have been a pioneer in engineering simulation technology for over 30 years. We bring the same philosophy to the electronic industry to enable engineers to collaborate on all aspects of logical, physical, thermal, and mechanical design from concept to manufacture. The electronic system design solution spans different engineering disciplines, from the printed circuit board design, review, verifications, and manufacturing with a suite of our products, with Polex, with FICO, high frequency and antenna design, SimLab for electronic cooling, thermal simulation, structural stress, and vibration analysis. I have a video describing the same. We also have the HyperSpice for functional circuit simulation. And of course, the entire solution is backboned and supported by the HPC and cloud environment at different levels. So we're also on the forefront of what we see as the next evolution of enterprise decision making. Throughout the conference today, there'll be a number of great presentations from customers showcasing the power of where Altair is today and the vision of what we can do together in the future. Always innovating, focused on staying not only one step ahead, but multiple, so we can help you take those steps together. With everything more connected, digital twins will be driving decisions and operational decisions. With data coming from many places, whether it be simulation data, live data from products in operation, or historical data, different types of digital twins will be created and connected to one another to provide a full view of driving decisions. A lot more to come from Altair in this space in the next 3 to 6 months. A pictorial representation of what I spoke about, again applying AI ML throughout the enterprise. I'll quickly go through some of the examples that we're working with our customers. This is Leonardo to define where and where sensors are included in the products to benefit from predictive maintenance. We see more focus on coupling simulation-driven twins and data-driven twins to provide a complete view, a digital thread. Again, with Rolls-Royce in Germany, we collaborated to develop a data-driven model to predict remaining useful life of engines in operation. We continue to believe partnering with our customers allows us to push the boundaries of our products and deliver stronger solutions. Vortex, like many customers, is leveraging IoT to their digital transformation. I have another example of reduced auto model using AI. For a detailed digital twin they created to reduce simulation time for this example, from 680 seconds to 20 seconds per simulation, while preserving the results' accuracy. Here, Mabe is leveraging data analytics to predict possible failures in the field to improve customer satisfaction. For many of our customers, the data is already available. It's about building a system that allows you to take advantage of the massive quantity of data and coupling it with simulation to design better products for the futures. I have a different example in the next slide from one of the largest banks in India, HDFC Bank, on the use of the Altair data products.
The new age digital era has prompted well-established business to think out of the box. At HDFC Bank, we see age of digital as an opportunity to redefine financial services by continuing to invest in technology to improve customer experience and enhance efficiency. Our transformation strategies planned around setting up of digital factory and an enterprise factory with the aim to roll out new digital products and services to serve the tech-savvy and new age customers of India with future-ready, resilient IT infrastructure. This would help us build a bank of the future, well poised to capitalize on this opportunity the higher digital adoption will bring to India. In this endeavor, our collaboration with one of our trusted partner, Altair, is helping us democratize AI, ML tools and empowering the credit analytics and innovation team. At Credit Analytics and Innovation, we build machine learning solutions to solve use cases around credit and fraud risk. Altair truly democratizes with giving simple solutions to simple and complex problems, leading to faster time to market and improved customer experience for my lending business.
That was Bharat Shastri of HDFC Bank. Again, moving on to high performance computers. Organizations like Jensen, which is the Johnson & Johnson company, rely on our HPC solutions for life sciences to scale in the cloud and grow their HPC infrastructure to support critical science and research, including the COVID-19 vaccine development. We see customers like Johnson & Johnson leveraging the convergence of simulation, HPC, and AI to optimize critically important work. Again, digital transformation for you, our customers, goes beyond just product development, expands the entire enterprise from system engineers to IT and DevOps, on the edge, on the cloud, everywhere. And again, my colleague Vishwa put up this slide. What I want to show you is the industry, the industry analyst, what they say about the growth of the market. So essentially what I'm saying is all our jobs are safe for the next few years. Okay. With that, thank you.
Thank you, Mr. Vishwanath Rao and Mr. Nelson, for giving a great start for this conference. Good morning to one and all present here. I am Beena Jacob, and along with me, I have Mahima Punjabi from the Business Development team. We are your hosts for this event. Before we continue, I have a housekeeping note to make. I would like to seek your cooperation in conducting this conference. Kindly switch your mobile phones to silent mode to avoid any interruption. Thank you. To start with, I would like to invite Dr. Royston Jones, the Chief Technical Officer of Altair, to present on the topic, Next Evolution of Twins to Radically Shape Our Future. Dr. Royston Jones is a CTO at Altair and the Managing Director of Altair's operation in the United Kingdom and Ireland. For nearly 40 years, Dr. Jones has been involved in the application of simulation to produce design innovation. He has pioneered numerous simulation applications and processes to inject product innovation to meet the business challenges of the customer. Recently, the focus has been the development of cutting-edge simulation solutions for e-mobility, including methodologies to reduce vehicle weight and optimize the multi-attribute performance of battery packs. He is a visiting professor of both Swansea University and Queen's Mary University of London, and a fellow of both institutions of mechanical and civil engineers. The floor is all yours, Dr. Johnson.
Wow. Good morning, everybody. First of all, I'd really like to thank Nelson and the Altair Indian team for inviting me here. In India, it's been nearly 10 years since I was last in India. That's been too long. I genuinely mean it that India is my favorite place to visit. So for 10 years, I've had withdrawal symptoms. Today's talk is asking the next evolution of twins to radically shape our future. It's quite a bold title, but I'm hoping at the end of the talk you'll sort of agree with me. I think there's a lot of industry talk about digital twins, And I think it shows that there's quite an inconsistency with the way that digital twin is referred to. It can mean different things to different people. For here at Altair, I think it's sort of very simple. It's basically creating a digital asset that can agree with the physical twin. And with that focus, you can select many different technologies to create that digital twin. So you can use simulation, you can use systems technology, surrogate models created via response surfaces, or reduced order models. One of the key ones is obviously simulation. And I just want to review some of the history of simulation and see how that's fitting into the creation of the digital twin. So I'll take you on my journey, hopefully, as I press the green button. Let's go back a long time ago to 1981. I think here you have Professor Zenkiewicz, who was the professor of the civil engineering department at the time. I was just finishing my undergraduate degree. Professor Zenkiewicz was renowned as being the father of finite elements, probably one of the fathers of finite elements. In his book, the finite element method was like a Bible. And you had to read a chapter every week. But what Professor Zenkiewicz spoke about when I finished my undergraduate and he's trying to persuade people to do postgraduate was something called a physical-based virtual reality. It was a digital twin. And in them days, that was quite visionary because I think what we saw was... sorry, I'll probably need to stay to the podium. What we saw was the emergence of video games. So the gaming industry had started, you had cars crashing into cars, but this virtual reality, this digital twin was basically on our agenda. And we're obviously a long way from that. I'm just changing my equipment here. This is one of my first applications. And this is just, this is all the elements that we can afford. So it's a long way from a digital twin. It took 4 days to run, but this is the journey that I started. It's over 40 years ago now, slightly under 40 years ago. And that journey's continued. And the technology has got more predictive. It's got faster and more, over the last decade, it's become more intelligent. But this is the journey that we're on. I think another inspirational figure is our CEO, Jim Scapa. This is his slide. It's a great slide. It basically shows, so here, the early 1980s, which is what I was talking about there, we're starting, and it was all about reducing physical prototyping. And that's how the simulation started. So there we were creating, using simulation, our own digital twins to reduce physical testing, physical prototyping. Then here you see the start of this sort of century, the emergence of simulation-driven design. And what this was driven by a lot, obviously the technology was starting to get faster. We could keep up with design processes, but technologies like optimization were helping to define the actual geometry. Geometry being the domain of the designer. Using technologies, we're collaborating with the designer, defining optimum geometry configuration. So once again, simulation was starting to create a real impact here. Over the last 5 years, there's been a massive explosion. Everybody wants an electrical vehicle. They want it in 2 years. The only way that they can do this, get that vehicle with great mass, great performance, is using heavy deployment of simulation. So more than ever, simulation is the key technology to product development and accelerating product development. I think we see the emergence now of data, and we're going to discuss that later. But once again, Altair will be that company who will The same way it's done with optimization, we'll start introducing data. And as Nelson showed, you can see the investments we're making to accommodate that. So let's move on a little bit now to the digital twin. And I want to introduce to you the most complicated product on the planet, and that's you. So let's take a look at the digital twin. So you can see I didn't do a medical doctorate, so here's my description here of this very complex product. So you have a body, you have the brain, and you have a nervous system. So if I wanted to create a digital twin of this complex product, I basically have to make sure that if I'm modeling the body, it's mechatronic, it's multi-physics, it's a lot more complicated. So my simulation now is no longer mechanical like it was in them early days. It's a lot more multi-physics. I need to start replacing the brain. You've got this really complex brain, the control system. I need to start building controls. And then from a nervous system, I need sensors, I need control signals. The data is going to be pouring through this sort of system that I need to collect from the sensors. So if you can create this digital twin of a human, you can imagine the power that you would basically have. If your digital counterpart was next to you, things like heart attacks, due to the fact that this is censored, your digital twin would be able to censor it. So the physical twin has the power because it lives in the physical world, but the virtual twin has great power as well. And that shouldn't be overlooked. Now and again, the focus is all on physical, but the virtual has great power. We can build it quickly. We can look at loads of variations. It's a time traveler. We can slow the time frame down, like for Crash, or we can accelerate it when we basically looking at, say, predictive maintenance. It's sort of really powerful, and I'll come on to that later. So why this analogy? I think this analogy is very important because this mimics what we're seeing out in the field. The products are getting more complicated. The products are getting electrified. So there's more multi-physics. They're getting more connected. They're getting more intelligent with controls. So the products are mimicking what I'm showing here, which is key. So let me show two case studies, which once again I think will show the way that the digital twin is basically going. So an important one, I think, a really nice one is, say, an EV battery twin. So, and I'll draw upon some of the analogies I made with the human twin. So within this sort of demonstrator, we have a typical battery module. Basically then that's hooked up to control sensoring. It's through a CAN bus connected to a PC. We've got Altair in bed, and we can basically manage this system from that PC. Now and again, when we're calling for load, the load has to go to somewhere, so it's going to a resistance bank. So that will start to heat them resistors when we call for load, and then we have a cooling plate to basically cool it. So in general, that's a system. So let's take a look at the body. The body in this case is a small battery module. It's got 44 21700 cells. It has the cooling plate. It's got buzz bars, but essentially that's what we call the body. Then the brain, it needs to model these events. So here, some simple events that we're going to model is that we're going to monitor one of the cells, and once it's reached a certain temperature, we're going to switch on the pump, and we're also then, in order to avoid damage to the system, at a certain point, we're going to switch off the current. So in this case, our solver, which is OptiStruct, it needs to respond to this. It's going to simulate a transient event, and it needs to respond to it. So in this form, you see here, something that I just explained, was that the current switched on. You can see at the top in red, We're going to turn it off at a certain time point. We're going to be monitoring a certain cell temperature. We're going to turn that on. We're going to turn the cooling on when we reach a certain temperature. So that's a system. So this type of event you'd probably is more akin to a system model like Activate. But here, the solver needs to respond to what's happening. So what we're doing is you can take your systems model and you can integrate it within the OptiStrut environment. So it's like taking the battery management system and integrating it into the solver. And the interchangeability between the solver and systems, that's something that will increase, because maybe the battery management system itself and the solver like OptiStrut, that'll be controlled by a system which is governing the whole car. So it's this interoperability of these solutions that help create this digital twin. So I spoke about the nervous system here. We've got loads of sensors on there, 16 sensors, modeling various temperature locations, the buzz bars, and the sort of coolant. So that's the layout. So let's have a quick introduction to the physical twin, and here we're just concentrating on what we call the body. So very quickly, there's the modules. You've got the instrument panel there. You've got this resistance bank, which is caged off because it can get really hot, up to 300 degrees C. That's it globally. This is creating the assembly, creating the modular pack. It was 3D printed, and then you see there the bonding of the wires between the buzz bars, which is how you're connecting the current to the batteries. So this is a quick introduction, looking at spinning it around a little bit, taking a look at it. You can see that the main sort of connections, a positive terminal and the negative terminal there with the big black wires. And there's the buzz bar system on top of it. And this is built with us. It's a great company. It's a rapid prototype company, but this took 1 month to actually build, which in battery terms of prototype, it's pretty quick. So let's introduce the digital twin. We already have a correlated battery model that we worked on, so we could knock this model up in a few days. So this is the model built using HyperWorks, and we're going to solve it using OptiStrut. So I think the twins, they teach one another. The physical twin teaches the virtual and vice versa. You use them in sort of tandem. So what I'm going to show you now is first of all, an initial result from the virtual twin. I think it's really cool. It's the first time that I've seen, and hopefully you, where we're showing multi-attribute results on a single model. So you see on the buzz bars, we're going to show how the current is flowing. On the batteries, we're going to show the temperature. And for the fluid, we're going to show some velocity contours. So that's a power that we built now into OptiStrut. So OptiStrut has got an electrothermal capability, and it's got a great hookup to CFD. In general, for these systems, we don't need to use very heavy CFD. There's lighter CFD representations or fluid representations within OptiStrut, which is more of a design concept. But due to the way that this cooling system was constructed, we're using CFD, which you can access through OptiStrut. So here you see on the top, these are the current contours. And this is just starting, and you can see that you've got the positive and the positive and the negative terminals, and you can see the little connection wires, and that's showing how the current is actually flowing. Remember the various stages that we're having of turning things on and off. You see the battery heating here on the underside. you're seeing the cooling being introduced. The cooling initially is stagnant, and then we turn the cooling on when it hits a certain temperature. So once again, these are the type of virtual tools which start to increase your understanding of what's happening in these multi-physics events. So there's towards the end, it's starting to cool, you're ramping the load off, and the cooling then constantly remains on as the battery slowly sort of cools down. And then here you'll see some sort of correlation results. This is thermal imaging that we use on the physical twin to see that's heating up and seeing hot spots. And here's just two thermocouples, one on the cell that we're monitoring to trigger the cooling, and then one on the bus bars. So basically you can see how we're creating this digital twin to basically replicate what is quite a complex physical event. So once we have this confidence, and here the attribute we're looking at is basically looking at the thermal performance, then obviously we can start unleashing the power of the twin, which I mentioned, and starting to plug in things like optimization. So now we're really utilizing the power of the twin. And this is just a simple study again where we basically place some logic inside OptiStrut, and then we see what it can do. So the baseline essentially is saying when we reach a certain temperature, in this case 30 degrees, let's turn the cooling on. And the cooling remains on, and the end temperature is 34 degrees. And we've used nearly 80% of that cycle where the pump is on. Now let's set up an optimization problem. Let's have the design objective as we want to minimize the amount of time the cooling pump is on, the design freedom that we want to give it, the design variation. Let the technology switch the pump on and off as it desires. Use a criteria which is related to a delta T for the gradient, and then let it decide. Let the optimization do its magic. But by the way, don't go over 37 degrees. That's our constraint. And then that's the result. We see that it's on for now 60% reduction we've got from that original 85. The pump is switched on and off 8 times. And if you do a cheap and cheerful range calculation, that's giving us 5 miles. That's just showing the potential about how we can use this technology. Again, since we in the OptiStrut environment, using the same single model, we can evaluate multi-attributes of this system. So once again, we don't have to build a CFD model, it's the one model. And then we're evaluating all these attributes. The thermal electric analysis, which you saw previously, but normal modes, the PSDs, the structural analysis, all within the same. And once we've got it in the OptiStrut environment, we plug into optimization. So there's just some of these attributes that we're evaluating. But once again, it's demonstrating the real power of simulation. And speed is of the essence. Speed is critical. It's just giving you an indication of how powerful this technology is going to become. So my second example relates to warranty. And warranty is one of, if you're involved with a company that's making any product, then from a company perspective, warranty is going to be one of the major business issues of your company. So typically within a manufacturing company, warranty will take nearly 2 to 4% of the company's revenue straight off the bottom line. Okay, so if you look at Jaguar Land Rover's annual report, 2022, you can see that their warranty bill is £750 million. That's a lot in warranty. So I think that the digital twin can basically be a key to significantly reducing warranty. Obviously, all the warranty issues are not directly related to structures, but a large part are, and I think that you can certainly reduce warranty. And I go back to why I think this. We spoke about the identical human and the power that that could have. What would the consequences be of having an identical virtual twin for some of these products? And I think it would have a massive impact on the warranty. So how do we create this identical twin? How do we go about that? So I go back to college again and my learning. If you create any simulation model, you always divide it into 4 areas. There's 4 areas of these models. And what you say to yourself all the time is, where am I not capturing the physics? So if I want to build this identical twin, my focus is on these areas, where am I not capturing this sort of physics? And, in general, you'd like some physical data, because that's a way maybe to get better material properties, so I can start to match better. But what we're now seeing, so physical data has always been something that will help us create a more realistic digital model. Now we see an explosion in data. We see data everywhere. We're data rich. So let's start to use this data to create this identical twin. So when we look at the geometry, for instance, we got a really nice nominal design geometry. We all know that this geometry isn't nominal. We all know that there's often a difference between the as-built and the designed. So let's try and quantify these sort of differences. We know that the material will have some variability. We've done lots of robustness. We understand probability methods. We can start building these things in. The loading conditions, load drives design. The biggest factor in design is loads. We start getting more intelligence from our loads. This is going to lead us to this identical twin. Similar to the boundary conditions we often approximate, we can make them better. And the analogy here is, this is the body, and around the body is the environment. So let's look at a framework now. This is quite an ambitious framework, but once again, I focus a lot here on sort of body and white, and let's see the steps we want to take to try and move towards this identical twin to try and reduce warranty. So manufacturing, we know manufacturing, stamping, assemblies, they're all going to create that deviation from our design. And we have technologies in there which can basically help us. Sorry, that's frozen. I'll restart. So it's nearly finished. Yeah, I'll just go down the one before that actually. Let's skip that one there, because that was a problem one. Let's go. Yeah, okay. Okay, yeah. Yeah, so we know that we've got simulation technologies which can try and reproduce manufacturing and assembly, and we can start building them into our model. We know we can do that. I think we talked a lot about gathering field data, and there's a fantastic presentation last night about Arthur Energy Bikes and how they're doing some of this thing. They're collecting field data. The automotive companies are collecting loads of field data. This field data we can start to use to refine our loading and get closer to the actual product. Warranty data as well. We gather loads of warranty data from dealerships. That's a starting point, but using that data and understanding that data is really key. You get lots of warranty data and start feeding this. All of this is, in general, this is hot data. We're getting all this data off the line, we're getting loads of field data, we're getting the warranty data, all this is hot data. So we're pumping this through, We're pumping it into Knowledge Studio. We're comparing each of these physical twins against the identical twins. And then we're using simulation to look at the cause and effect and really getting to the core about what is causing this variation, what are causing these warranty issues. And that, I think, is the journey that the companies are going on, creating these machine learning models, understanding that variation, and then coming up with either live mitigation in manufacturing or basically refining your design processes or your manufacturing processes. So you have to start off small. This is a big chunk. So this is, so here, this is just looking at the sort of tailgate, and there's loads of issues, no matter what the automotive company is, around that tailgate. It's a real battle area, if you like, for warranty issues. And you see the various types of warranty issues here. You're getting scan data off the line continuously. You want to collect that data, understand that data, start looking for patterns, create machine learning models, and then just initially, just look at the warranty data you're receiving and the physical data and see whether you can find patterns. That's the first stage. And then the next stage then is to start looking at simulation, enriching your simulation, because once you've established a link between your simulation all the way to your warranty data, then essentially you can start to reduce your warranty issues. And this is the goal with the identical virtual twin. So in summary, I think we see the technology moving rapidly. Our clients' products are becoming a lot more complex. They're more electric, more connected, digital manufacturing. We see a massive amount of acceleration. And increasingly, it's becoming impractical to insert physical prototyping into program milestones. And the onus then is more on virtual verification. We all understand the potential pitfalls of that, but this is the way to go with more intelligent twins. So we basically looked about the development of intelligent digital twins, which basically have got control systems embedded in. We've talked about identical digital twins, and with Altair, it's this one total twin is what we're basically striving for. And I think that this is the solution to efficient product design. So all we see is this simulation powered by data. We just see that increasing. So I'd really like to close with just one other observation. And this is from, Nelson showed a clip from Peter Rawlinson, CEO of Lucid Motors. And I think it really chimes with what I'm seeing out there, is that, just play the clip. The future of Lucid going forward, I mean, if you look at this automotive landscape, it's just changed so quickly. We have lots of new players and established players, and how do you see that going forward in the context of Lucid?
Well, I think it's going to be a tech race, and I don't think people recognize that. I think that this is not about buying commodity solutions off the shelf. You can't just go and buy an electric motor and an inverter here and there and kludge it together. And that's the way that so many OEs are approaching this. And down to the best of my knowledge, it's only Tesla and Lucid that design, develop, and actually manufacture all this stuff in-house.
So the key thing I wanted to play was Peter saying that he believes that it's a technology race. And due to the nature of the products that our clients are now producing, you can see that they're starting to reposition themselves within the market. So even real conventional players who've been around for centuries, like Volkswagen, they're basically out there now saying that they are going to be a technology company. And the first part in that technology journey for them is redefining their design process. So you see them positioning. So the real athletes in this race are the engineers. So you are a valuable asset now in this company. So in the technology race, the engineer is really key. So I think with that, I think I just want to hope you've been inspired by what presented here. I think hopefully you can go back to your companies, give birth to digital twins. I think Altair would obviously like to be part of that process with you. But yeah, I'd like to thank you for your time. And with that, I end my presentation. Thank you very much. Thank you.
Thank you for sharing your expertise in this session, Dr. Jones. It's now my pleasure to introduce our next presenter, Mr. Michael Dumbach, the Senior Vice President of HyperWorks at Altair, to share his insights on Altair next generation user experience with HyperWorks. Over to you, Michael.
Hello, thanks for your patience there. I'm Michael Dombach. I'm a Senior Vice President for HyperWorks, and I'm going to be talking to you a little bit about our motive for moving to the next generation of HyperWorks suite of tools, which goes beyond just the user experience. So I'm going to start with a little bit of a reminder that HyperWorks has been the flagship of Altair for the last 30 years. And we have been involved in virtually every product that you see on the screen here, from the aircraft carrier in the shipbuilding to the fighter jets in the aerospace, the turbine engines that run the jet fuel for those jet aircraft, and also the steam turbines running off of the fission nuclear reactors in the bottom of the aircraft carrier. We also are in space industry, and most of you are already aware we're pretty heavy in automotive as well. So what I want to talk about today in the next 20 minutes is how we're approaching dominance in this area for the next 30 years. So the reason why we've had dominance is not because we're necessarily the best at everything, okay? We've had our customers tell us, this, that, the other thing our competitor does better than us at these line items, and that's fine, it's healthy, it's great to have good competition, it keeps us honest, all right, and it makes us work hard to solve all those problems. But the value of what we bring to the table is really how the Altair unit system works, okay, and that is providing flexibility and value, and I'm going to talk about later through the presentation, scalability of that value. As we acquire different technologies, and that could be solvers, it could be pre and post in a different vertical, as we acquire all those technologies, it becomes difficult to make sure that our customers can leverage that value as soon as humanly possible. And that's where the next-gen user experience comes into play. So this is an old slide. This is a slide where James Dagg actually introduced our plan to move to the common user interface. In 2019, we introduced a ramp function to get us there, and essentially through COVID, we ended the ramp function. So in this last release, and I'll show the timeline in a minute, we've kind of blurred the lines between the products. In this particular picture, we've got Compose, HyperMesh, SimLab, Inspire Studio, Inspire, Activate, all with looking the same look and feel. And this is really blurring the lines between the products. And I think it was Nelson that mentioned this earlier. That's exactly the goal here. By having all of them have the same congruent look and feel and ease of workflow across all the product suites, not only do we have the goal of reducing the training costs of a user switching products, but eventually we want to have all the products look like they're the same and they're synonymous and there isn't a product. You don't load or launch a product. You actually load the Altair suite of tools and you leverage modules that are the best from each of these products. And that is the biggest motivator here. So let's start with the largest, most complex models. This is definitely where we're going for the next 30. Right now, HyperMesh is the go-to process for large model handling, for having multiple models across multiple domains in multiple regions of the planet. Also scaling models between 0D and 3D. I've got an example here of turbomachinery. I'm really glad to see the 1D flow simulator up here. That's pretty cool. Not necessarily HyperWorks, but it fits into the 0D to 3D that I'm going to be talking about. And then full management of subsystem connectivity, which brings me to my next slide. So some of you might be aware, but we're kind of phasing out the component in lieu of the part. This is because it's completely solver agnostic. The component was developed a long time ago and started with Nastran and then Abacus and eventually OptiStruct. And as we added solvers, it added complication. The part and the subsystem and now the connectors that support the two allow us to seamlessly interconnect those things, completely solver agnostic. Okay? And that allows our customers like Boeing and Airbus to share an entire fuselage or a wing section between Japan and Germany and the United States, and connect the dots and have traceability of the assembly from CAD all the way to test. So here's an example where we've got, not only is the HyperWorks user essentially mapping from one BOM file from the CAD system, that can be mapped to a PLM system, and we have different variations of the PLM system. We have the customer's PLM system, and we have a simple file structure, and then everything in between. The reason why I like the 1D flow simulator here is because our latest release got us into axisymmetry finally. This is something that I personally have a stake in. I was just at this year's ASME Turbo Expo in Rotterdam, and the biggest money maker there is that Europe wants to be net zero carbon emissions by 2030. Very, very ambitious goal. And everybody thinks that is electric cars, okay? Electric cars are great. That's fantastic. We definitely need to do that. But one of the biggest topics at this conference was if you flip the switch right now, and every single car on the road, just in Europe, every single car on the road was immediately gone over to electric, the power grid would only meet 9% of the capacity, okay? So everyone's like, oh, turbine engines, oh, it burns gas, okay? But I'm sorry to say, you're still gonna have to get your electricity from somewhere, and solar and wind are huge factors, no doubt in my mind, but they can't scale to make that 2030 target, okay? So Europe is looking at fusion, they're looking at hydrogen, they have sustainable aviation fuels, where they're essentially pulling carbon out of the atmosphere and generating kerosene from the air and water, with, of course, energy from somewhere else, which is going to end up being fusion. All these things need turbo machinery to run, all right? Your 787 is still going to need a turbo, it's still going to need to be powered by a turbine engine, and your power plant for your nuclear power plant is still going to have to convert that heat to steam with a turbine engine. So finally getting us into axisymmetry, cross sections, and making those models, processing those axisymmetric models from weeks to an hour is a big motivator there. So we're going to be there for all these governments that are subsidizing all this effort to get that power generation to meet that electric car capacity. Also, the agnostic scalable infrastructure. I mentioned this in the beginning as to what helps us win here, and that is engineering neutral entities and open source HDF5 map containers, which is what I'm going to talk about next, and our Python APIs that are used to do the whole thing. So let me start with what it looks like before we do the MDI interface. So today, Altair has a very large portfolio of tools that deal with our designers, our CAE processes and optimization, our system modeling tools. Hopefully you recognize a lot of these logos, multi-physics, and data analytics. In order to get all these to work, though, a lot of our customers, and along with some help from Altair people, have gotten all these things to connect the dots to create these process flows. And each one of these arrows represents some kind of file import or file export or conversion or reading of an XML, mapping that data from a result from one program and mapping that to a boundary condition of another, okay? And this is a pretty complex process, and our customers have been doing this. I have been doing this for quite a long time, and it becomes a mess, and it's difficult to maintain, and it's costly to maintain. So what we're doing here is we're essentially mapping all of these tools to one common meta-descriptor interface, meta-class descriptor interface. So what this allows us to do is you store all of the data in a binary, and each client is aware of the format that their entities need to be in to be mapped to that binary, and then each client can pull that content directly from the binary without any translation, without any parsing. It's just A to B. And it doesn't even need to be an Altair product. Since it's completely open and uses Python, any customer can use the same meta-class descriptor interface to access the data and even use a third-party tool. You could use Excel, or you could even use one of our competitors. It's completely open. So this is our meta-class descriptor interface, and this is what's going on behind the scenes. In the very first slide, I showed you James' old slide that shows all of the front end is going to look and feel the same, okay? We're there, all right? Now I'm showing you what's going on in the back. You don't necessarily see what's going on, but this development has been ongoing all through COVID, okay? And we haven't had a chance to talk about it since 2019. So this back end is what's going to end up finishing the puzzle. So we're going to accelerate the modularization. I haven't talked about modularization yet, that's coming up. But essentially, we're breaking down each of the products, this is SimLab, Inspire, and HyperWorks, into smaller pieces that can be shared across the whole organization. This is huge in a couple ways. The first one is, you get the best of the best. You get the best module from each client and you can use it in all the clients. And then secondly, it reduces development effort. And to you, that doesn't mean a whole lot other than we're moving faster for you because we're spending less resources doing redundant development efforts. This allows us the definition of neutral libraries for software components. This is also important for having engineering entities that are common and reducing the amount of conversion when you switch particular solvers. We have common Python API across all the applications. So the Python API is used to interface with this backbone, or this back end, we're calling it. And people coming out of school know Python and can interface with this interface with our binary to pull that data. And it also enables cloud deployment. When we're pushing to Altair One, we're going to be pushing from this common database, not from each and every client. So this is sort of what it looks like right now. We've got the connections between Inspire, SimLab, and the HyperWorks products, and then we also have the cloud, and then we also have our own solvers going through our data. So through the MetaClass descriptor interface, we can connect all the dots through the common data model, and that's how we're talking to each other. And again, it's completely binary to binary. And you no longer have to do a file import, export, and convert entities back and forth between the programs. So the first step was to get everybody on the same GUI, and we're there. And the second step is to complete the backends, so now you don't know the difference. You don't know you're in HyperMesh. You don't know you're in Inspire, and you don't know you're in SimLab. That's the goal, that's the vision. Everyone has been asking about Python as far as I can remember, and I wanted to give a little snapshot of what that looks like, because we're putting Python in essentially everything now, and it starts with this common backend, okay? So this is just a little bit of a picture in the 2022.2 release. We're going to have the infrastructure laid out to do some basic Python operations, but that is a major motivator for us. This is a very high priority, and I wanted to make sure you saw this timeline. Okay, so now moving to coming up with solutions with these modules. So now that we're talking about breaking down everything into a different module, and we blur the line between the products, we're getting away from the definition of a product altogether, okay? Right now, we're taking each of these modules, and we're allowing the users to build a solution with the best of the best with each of those things. And I have a couple examples of those right here. The Sketcher. The Sketcher was really the best of the three, and this came from Inspire. And what we did was we modularized it, and now it's available in the other two clients. And this, again, this was not a 3 times development effort. This is one development effort that became a module to be shared amongst multiple clients. And the number of clients doesn't necessarily have to stop at those 3 products. It can go beyond that. Another example is the Design Explorer. And I have to emphasize here, blurring the lines between the products. Nelson said it, and I think Vishwa may have also referenced this as well. But we're really trying to make sure that the user doesn't know that they're using multiple clients. And Design Explorer is probably one of my favorites. We have users, I can't say the customer's name, but they have an intern that essentially learned how to use HyperWorks with Design Exploration on their own. No training, just what was available online. They ramped up a couple days on the job, and they were building the model, they were welding the model, they were morphing the model, which again, morphing is the poster child in my view of how good the interface is. And then they were going to Design Exploration, right? So we've got 3 different tools there. HyperMesh and HyperStudy are the 2 that require the largest amount of ramp-up time, okay? Typically, we need to have some training in HyperMesh, and we need to have some training in HyperStudy just to get through that process. But here we have an intern that finished a job all the way through a DOE faster than a veteran of 20 years did that knew HyperMesh and HyperStudy, okay? So there's 2 major points there. One point is the usability of the interface allowed that to happen. And the second thing is making all these interfaces congruent and creating a back end that's congruent allows the user, they don't even know that they're using all three of those modules, okay? But now they know how to do a DOE. And instead of just putting hyper mesh on their resume, they can put hyper study on their resume because they can do a DOE, they can do optimization, and eventually stochastics. So the other point I want to make with Design Explorer is that it is a common module now. So it is available in both HyperWorks and Inspire. And again, this is one development effort. So the amount of time that our team has spent developing this infrastructure over the last 3 years is going to enable us to move a lot faster for all three clients. Another example here, and this relates back to the turbo machinery as well. In this example that you have on your sign here, we've got the 1D flow simulator. That's essentially a 0 and 1D level. But I mentioned before in turbo machinery, we finally have axisymmetry, so now we have the 2D, and of course we have the 3D. But being able to scale those back from the low-level design to the high-level design seamlessly is another example where we're leveraging the best of each module and then creating a process that works for everyone. Another acquisition, I believe Nelson mentioned this, we acquired S-Frame, I think about over a year now, maybe going on 2 years. And now they have essentially allowed us to expand into the architecture, engineering, and construction space, which is what AEC is. We've already been in this space a little bit for joint design and for small components, both with Inspire. We even were involved with SOM on the federal building with HyperStudy, Inspire, and HyperMesh. But now we're in there guns blazing, okay? On the design side, model building and operability, optimization, and of course BLAST and CFD. Again, integrates CAD and solver agnostic tools that has the largest solver portfolio underneath the hood. Okay, so how are we tying each of these products together? Pulse is sort of our next-gen process manager. So for those of our customers that have been writing processes with the old process manager, this is a Python-based way to connect the dots between the clients. Right now, it's a block diagram based, and it does reside on the desktop. We are prioritizing cloud enablement of this tool in the next couple of years. So stay tuned for that. We're going to be scaling it up. There's a lot of excitement about it on how to connect the dots between the products. But for the time being, if you want to have one end-to-end workflow from one to the other, this tool is using Python and connecting to that common data model. So the support for the entity types in the common data model is going to grow from release to release. So this will become more powerful with every point release. It has conditional statements and multiphysics, and I heard multiphysics mentioned at least 3 times before I came up here. Another aspect that we're working on is the cloud-based enablement. Obviously, the PLM connectivity and the STM connectivity has been very hot for the last several years. We've got the Altair One platform now, and we're finally connecting the dots on the pre-side and the post-side. So one example here is the Altair One viewer, where we're taking each of these results and porting it to a web-native viewer that is supported in Altair One. And we're hoping to have that delivered by the end of the year, so in our January release. And then some of you may be aware, I think Nelson mentioned this as well, we acquired Cassini, and we're hoping with integration with Cassini and our Altair One Cloud, they will help us accelerate that development as well. Another aspect that I want to talk about is the machine learning AI component. We are already using this for optimization. We talked about the design exploration. We're doing it for part recognition, meshing, feature reuse. But my favorite personally is the expert prediction. So here are our engineering data science initiatives for CAE modeling, and I have a few more slides on these if you go to the model assembly session. For CAE modeling, we're using Part Search, Shape AI to identify common parts, also common fasteners. On the AI side for optimization, we're essentially doing real-time predictions and clustering and labeling of results This one particularly is probably my favorite use of it. Because think about it, you've got a DOE that may do 1,000 or 2,000 runs, and now the user that is trying to post-process all those runs, instead of post-processing 1,000, 2,000 post plots, they're now analyzing 3 or 4 clusters of post plots. And that's a huge, massive time savings for post-processing a large amount of data. And then predictive analytics, this fits into sort of what Royston was presenting earlier in the digital twin space. And the turbomachinery is a perfect example of the digital twin space. The FAA mandates specific maintenance on that turbine engine, and to have a digital twin available to it, the same way UPS has been doing this for decades. They know exactly when to change the brakes on that truck before those brakes go out, just based on the mileage. And they have their own digital twin on pencil and paper before FEA. So to do that with a turbine engine, though, that requires some heavy-duty analysis. I already mentioned Design Explorer before. This is just another example of where machine learning is fit into play. I use the design of experiments example, where clustering of the results is a perfect use case for that. So back to the original point of the presentation was, how are we going to make sure we are the flagship for the next 30 years? All right, and it's not going to be about every line item feature, this, that, and the other thing. It's going to be about providing the most value to our customers and being scalable and flexible. But more importantly, it's about making the user scalable and flexible. Okay? I'm going to talk about that in a second. So as I summarize here, I want to give you a heads up that the old interface is going away next year. So in our next release, and again, our next release has been moved to January 1st, we have been regularly releasing on a good schedule for the last 2 years now. Our marketing and sales teams have asked us to release instead our next point release in January. And in that release, we're going to be turning off the old interface, but it'll still be there. We're just going to discourage its launch, okay? And then you're essentially going to have until the August release, so a year from now, when it will be completely phased out, okay? So I'm trying to give you some motivation here. We have essentially been transitioning for 3 years now, so hopefully this last year will not be a big deal for a lot of you. So again, how are we making the user scalable and flexible? So now imagine if you're that intern that was able to pick up Inspire or Hypermesh, and then all of a sudden you're doing a design of experiments faster than your colleague of 20 years experience. How do we make that person scalable? If they know the same interface, then they know how to use all the tools already. The learning curve is already half done. They just need to learn the tools of each of the products. So if you share all of these tools in the same unit system, which again is what adds value to our customers by using our tools, and then fading out the differences between each of the clients, now you've got the overhead cost for training a user from client to client is now gone, and that training cost is now offset by knowing all the rest of the tools because the interface is similar. So becoming an expert in one of these 3 tools and then easily becoming a novice in the other is a key way to make the user valuable. And how do we make sure people are motivated to do that? Well, if you have just Hypermesh or Hyperview on your resume, and this is as an end user, and now you're able to add the entire Altair suite of tools in your resume because it's very easy to switch between all the tools, that adds value to you as the user, okay? So both ends. The employer sees a huge amount of value in training costs that essentially are reduced from client to client, and the end user now can expand. They can expand their sphere of influence from, I know Hypermesh, to now I am familiar with SimLab. I'm familiar with Inspire. I'm familiar with Activate, okay? So you can expand your sphere of influence. And in my view, that's growing your career and getting outside of the box, all right? So just in summary here, I want to just reinforce the idea that not only is the user experience a necessary part of this transformation for the next 30-year flagship, but the back end is as well. And when we connect the dots with all these clients, it provides value, scalable, and flexibility for everyone. And the future is scalable, and the future is flexibility. And that's all I have. Only forward. Thank you.
Thank you for sharing your expertise in the session, Michael. We will now dispose for a coffee break. The tea and coffee will be served outside the pre-function area and outside the main ballroom. So we also have technology booths that are set up outside. So please do visit them for more information on the new Altair technologies outside the main ballroom. So we would also appreciate the event feedback that will help us improve the experience for the future events. There will also be a lucky draw on the feedback response where one of the participants will be eligible for a prize. So please do go ahead and scan the QR codes outside. Thank you. We will resume back at 11:30.
Always say we are going to take a 20-minute break and then the time and then repeat everything again. Sorry. Because people start leaving as soon as.
Yeah. So time is.
Well, that's okay. And then I told him before lunch he will put that the QR code also over here, so people can then point out and.
இல்லை நான் ஒரு டெம்ப்ளேட் மாதிரி ஒன்று ரெடி பண்ணியிருக்கேன் சார் இது நான் ஏதோ பண்ணல சார் நான் இங்கே
conventional wisdom says that to achieve something new, we must work within established boundaries, parameters, silos. That the size of an idea is determined by how much it pushes its limits. So what happens when there are no boundaries? What happens when the barriers separating creativity from analysis are removed? When we can refine ideas as quickly as we dream them? When insights emerge from an ever-growing sea of detail? What happens when we're no longer constrained by the limits of the physical world? We are Altair, and these are the questions that drive us. To bring together the most powerful forces in technology, across every domain of humanity, throughout every mode of industry, we enable innovative minds to advance infinitely, to change tomorrow together, to find out where innovation will take us, when instead of testing the limits, we remove them.
Welcome back to the conference, ladies and gentlemen. Now, we have a session by Ms. Lata Chembrakalam, the Head of Technical Center at Continental Automotive India, to present on technology and development trends in automotive. Lata is a dynamic business leader with close to 3 decades of experience. She joined Continental in 2021 as the head of TCI. In her role, she is responsible for engineering competence for global and local markets, focusing on automotive technologies that include autonomous mobility and safety, and vehicle networking and information. Her expertise includes building powerful technology teams which create value and differentiation for the business. She is also a certified coach from CFI. Lata holds an engineering degree in Applied Electronics and Instrumentation from the Trivandrum College of Engineering. Over to you, ma'am.
So very good morning to all of you. Can I have a response back? Very good morning. Yeah. So happy to be here with the Altair conference. And I was also just telling that it's always nice to see the in-person events after 3 years. Yeah. So nice to have the human feelings around. So today I will take you through some of the technology and development trends in the automobile. I've been in the industry now for 30 years, and majority of my time was spent in the mobility area. So some examples of that. So before that, I would like to tell you about our company. I come from Continental. So Continental is a German organization, fairly international, I would say. And there are 3 business areas that we work for. One is the Continental Automotive. You have the Continental Tires and the ContiTech. It's a leading player in the autonomous mobility area. And I would say one of the first to market the software-defined vehicles. and we also have an industry benchmark in tires. And last but not the least, passionate people at the center, more than 190,000 employees globally. So that's what we are. If you look at the different business areas inside, we cover almost everything in automotive except for the powertrain. So safety and motion, which is including the, all the safety systems, the airbags, and also the hydraulic brake system, vehicle dynamics, and so on. Then we have the autonomous mobility, the user experience, which includes the HMI as well as the other topics. Then we have the smart mobility, cloud solutions, and also architecture networking, which is majorly focusing on the HPCs. We also have a horizontal, which is running across the business areas, which is focusing on the system and software excellence, where we also have a lot of center of excellences with respect to artificial intelligence, cloud, and so on. So coming to the India organization, I lead the India organization, which is called Technical Center India. We have close to 4,700 people here, all engineers. And I would say that this is the largest R&D center for Continental. And it's kind of growing year on year, 18 to 20% in volume as well as value. So we are a global engineering center for where we have the COEs, a lot of global ownership for products, projects. And specifically when it comes to certain ownership, we are also responsible for a lot of Asian projects, Japan, Korea, and China. And also regional R&D center for development of the Indian market. So a lot of focus on innovation. There are multiple COEs for innovation, product, software system, agile. So would like to take you through some of the things, what's happening in the industry. So what is the industry aiming for? What is the mobility industry aiming for? So when we look at our older generation, or maybe the generation where I come from, when you ask, what is the thing that you look in a car when you want to buy a car? So what we used to say, we need to have high mileage, yeah, what is the price point, and so on. But I think that era has changed, and we are now looking at three main things. One is the joy of use, the ease of use, and the safe driving. And of course, safety is the most important topic there. So three pillars, if you look at it, one is the safety and security. Security, I'll come to a little bit later. Connectivity, very important. And last but not the least, a personalized experience. Everybody likes to, that's where you see there are so many variants of vehicles and you have a personalized experience coming in. Now, what are the major trends which are happening in the industry? I would say it is called EXI. It is electrified, automated, connected, shared, and the most important, which is coming up, is yearly updated. So kind of the car is coming like a cell phone now, because when you have the software updates coming in, and I think the vehicle is also moving in that direction. So what's happening here? The classical vehicle was something which always took us from point A to point B, and that has kind of transformed, and I would say that the modern vehicle is nothing but, it is an IoT device which is always connected to the internet. So that's how the transformation is happening in the industry. And we also say that software is eating the car. So why do we say so? If you look at a car which is currently there, which is kind of a medium-sized sedan, one of the premium OEMs, if you look at it, it might have around 100 million lines of code. Let's look at a fighter aircraft. Maybe it is a fraction of that, right? So you have 100 million lines of code, and the complexity of the software, the function that is coming into the software is increasing day by day, right? And the number of sensors which is increasing, because we are talking about joy of use and the personalized experience, which means that the sensors which are coming into the car, the multiple IoT devices which are coming into the vehicle is kind of increasing. So that's why we say software is eating the car, and from 100 million lines of code, it is expected that by 2030, we will have around 300 million lines of code. And if you look at the value of the code at this point of time, the value of the car, the software is probably 10% of the value of the car, which is also maybe going to be double or triple in the next year. So that's the transformation which is there in the mobility industry now. And if you look at innovation, major part of the innovation which is happening in the industry is related to software. So that's the transition which we are seeing in the last decade, I would say. So now when you look at, there are two things which we need to look at when this transformation is happening. So one is, what are the technologies which are coming in and how does it really affect us? And the second thing is that how does the development methodology itself change? And that is where I would like to bring in some use cases from organizations like Altair. So when we look from the emerging technologies, I've just listed 8 of them, but it's not limited to 8. It is much more than that. So the first one is artificial intelligence. And cybersecurity, very important, because as I mentioned, the vehicle is something which is connected to the internet all the time. So cybersecurity becomes a very important factor. Cloud computing, then the 5G coming up in a big way. And if automated driving, especially the L4 and the L5, have to be a reality in the future, then the 5G has to come because the speed, the latency, all this become a major issue. And we are talking about something which is much more safety critical, right? Then you have the blockchain technology coming in because of the secure payments that we need to have, maybe starting from a charging of an electric vehicle to maybe an insurance payment to everything. Can we have this automated distributed ledger technology coming in with the blockchain? Then you have IoT connectivity everywhere, obviously, augmented and virtual reality starting from testing to marketing to every field you can see it. And data is king. Because data is having so much of power these days, because even the purchasing power, the engineering processes which we want to adopt, everything, a lot is dependent on data. So this, I would say, is kind of icing on the cake, but the core engineering remains the same. And what's the core engineering? When we talk about maybe an electric vehicle, it can be your, the motor and related components. Then if you talk of an IC engine, it can be something related to your air system, exhaust system, and so on, right? So the core engineering is there, definitely, irrespective of the type of the vehicle, whether it's electrified or IC. And then on top of it, you have the emerging technologies. So due to time, maybe I would look into 2 topics a little bit more in detail. So one, I would say the artificial intelligence part. I think the previous speakers already spoke about artificial intelligence, the impact that we have with respect to the digital twin and so on. But when we talk about the vehicle itself, would like to bring in certain use cases. So one is, it is really the brain behind autonomous driving. And when you talk about L5, which is the highest level, which is the driverless car, what is basically happening is we are putting AI behind the wheels instead of a human. So that's going to be a game changer, and that's going to be the future. So there are 2 things there. One is you can have vehicles which are driver-assisted vehicles, and the highest one which is driverless. And if you look at both of them, AI plays a very important role. Another one is looking at the driver behavior itself, and it starts from recognition of the driver, whether it is biometric or whatever, because, and then even the settings of the car according to the recognition. For example, if there are 3 users of the car in the family who have different preferences with respect to their height, with respect to their aircon, with respect to their, the infotainment and so on, the moment it is recognized, the car is already setting into that condition, right? Then you have the driver monitoring, which is a very important factor when it comes to safety. That, what is the body language of the driver, is the eyes drooping, what is the body position and so on, so that it can have an alert which is there in the system to monitor the driver. And another simple example is also the infotainment controls that we have, where when the driver is driving, you can have a simple hand gesture and then control the infotainment system. So these are some of the examples which are there. Individualized marketing, I think all of us are familiar with Google. Individualized marketing is something which we experience every day. And the same thing is coming in the modern car. For example, if the vehicle is able to sense that it's, normally the driver has lunch at around 12:30, and then he or she prefers maybe a pizza, you get an alert telling that, hey, you have a pizza center maybe, so many kilometers down the road, and do you want to order it from the car? So that's the kind of personalized user experience which is going to come in the future. Predictive maintenance, obviously, I think, previous speakers spoke about it. I think predictive maintenance is a big thing. Also, a kind of a cost-saving mechanism, which is also coming in the industry. Again, another interesting topic which is coming is the automotive insurance itself. Yeah, so which means that what is the insurance premium that you need to pay? And if your driving pattern is rough and harsh, maybe you get more premium to pay. And if you're a safe driver, you might have to pay less insurance. So this is also coming up that, where we use AI related to the automotive insurance. And last but not the least, digital twin application in many things. So AI is a real game changer in the mobility industry at this point of time. And if these automated vehicles and connected has to be a reality, there will be a lot of AI which is being used. Another one I would like to touch upon is the cyber security. Yeah, so why cyber security? It's continuously connected to the internet. It is like as vulnerable as your mobile phone, or maybe more vulnerable because it has more value, it's a valuable storehouse of data. So it's very important. And the cybersecurity is one of the technologies which was existing, but which caught the importance or attention of the organizations only a couple of years back. I don't know how many of you remember there was a Jeep attack which was planned by some of these, hackers, where they looked at, they could topple the vehicle sitting somewhere else, and that is where cybersecurity caught a lot of attention. I think some of us belong to a generation when banking came to the phone and we were really not sure whether we need to do banking because we were not sure whether money was safe, right? So I think that's the same situation we have with the driverless car at this point of time. Are we really trusting it? Are we really, letting the artificial intelligence behind it, and also the cybersecurity part as well. So there are high risks which are associated. So when we look at inside the vehicle itself, you have a high number of electronic control units. And if one gets affected, the chance is that many of them gets affected. The second one is, since it's an IoT device connected to the world, this means that vehicle to the external world, if you have something infected inside the vehicle or outside, there is still a chance that you will have, the cybersecurity threat happening all across. So you have the in-vehicle services, you have the OEM backend services, production, maintenance system, entire thing can get affected. And you can also take a case of an electric vehicle where the electric vehicle probably can be connected later to the charging structure and later to the grid as a whole. And in the connected system, the V2X, which is coming, the vehicle to the infrastructure and so on, the risk that we have with respect to cybersecurity is really huge, and that's what the industry is battling now. So there are a couple of things which have happened in the last year. The UNECE, they have brought up something which is a work package, which is looking at identifying and managing the cybersecurity risks which are there. And they are also telling that there are certain testing standards which are coming in, and the risk assessments have to be done if the vehicle is to be rolled out to a different market. So there are exit barriers which are bringing and so on. But the most interesting topic is, the hackers are also getting smarter, right? So there is no checklist which tells that, these are the 10 issues that we have and these are the things that you need to take care. The hackers are getting smarter and smarter. So every time you need an update of this technology, and cybersecurity is kind of a moving target, and this is a real challenge for us in the market, especially because of the skill availability that we have. And the second thing is as I mentioned, the very smart hackers across the globe, yeah. So, digital twin, I think, I don't want to talk about it because I think the previous speaker spoke about it. You're looking at basically a sense, plan, and act in terms of the digital twin. And there are multiple applications in the automotive industry in which it is being used. One of the common ones which we are talking even in the two-wheeler at this point of time is to look at the state of charge and the state of health of the battery, and using digital twins for that. So this is something which is there. So there are different topics we talk about: the product twins, the system twins, and the process twins. And if you look at every life cycle in the value chain of the automotive industry, digital twins plays a very important role. And that is where organizations like Altair can really contribute a lot, because there are a lot of tools and systems which are available, which is helping us to develop this and go further in this technology. So what are the trends that are driven by the software? Yeah? So how is the industry changing in the automotive itself? The first one is the explosion of the complexity itself. So one is the expectations of the customer, and second thing is also the regulatory requirements that we have. Yeah, and as I mentioned, 100 million lines of code or 200 million lines of code is not a joke to handle. So the complexity is pretty high. And what is the differentiation that OEM can bring in? It's a software-defined differentiation, because as I mentioned, many of the innovations what we have in the mobility industry now is powered by software. We have a high number of variants. Earlier, maybe 30 years back, we were talking about maybe a Premier Padmini and an Ambassador and no ECUs. Life was simple, right? But right now, we have got hundreds of ECUs, and we have a lot of regional requirements coming in by the customer preferences, not only by that, but also by the regulatory bodies. So there are variants. The automotive industry is kind of, I would say, exploding, and every OEM is bringing in multiple models, and each of these models are customizable because we are talking about joy of use and personalized experience. So this is what is kind of changing. The other challenge what we have in the automotive industry is, see, maybe you can compare a mobile phone and a car together, but we throw away mobile phone after 2 years and we buy the next one, even though you have updates in between. But normally when you talk about the longevity of a product, it is pretty high. I mean, I don't think that we buy cars for 2 or 3 years. I think especially in an economy like India, we use car maybe 8 to 10 to 12 years. So the long time maintenance and the long product lifetime is a challenge what we have. And with the number of patches coming in, with the number of over-the-air updates coming in, we also need to keep the entire thing up to date. And again, the cybersecurity risks which are there, so which means we need to also keep those things up to date, which is a challenge. And if you look at the industry, other than the other industries, automotive is an old industry, and the software inside they have a legacy way of developing. Even though we talk about different platform structures and so on, we still have not transformed into a very scalable structure in many of the areas. And there is a lot of reusability because the whole thing is very expensive. So what happens is keeping track of the legacy software and the electronics which is there in the vehicle, along with providing updates and adding these new technologies into it, it becomes a challenge, right? And also vague standards. I can't tell that we have, it is completely standardized. We have been talking about AUTOSAR quite a bit. We have been talking about many other standards, but we are not yet there. If you probably talk about a sector like defense or others, the standards are much more important and much more followed, but automotive industry is still chasing up with some standard. And especially in the new areas and the new technologies which are coming in, a long way to go which are there, and OEMs also sometimes, especially in countries like China, sometimes they also kind of interpret their standards accordingly and build it. So it becomes more difficult. For example, for a supplier like us, as well as the OEMs, it becomes much more complex. And you have multiple players in the entire software chain. Earlier, you have an OEM and you have a system supplier and a software, everything comes together. But now look at the industry. So you have multiple players there. You have multiple suppliers, tier 1 suppliers giving it. You have open source code, open source code which is coming in. You have got startups supplying to an automotive. So if you look at the chain, when you are producing a ECU software, we might have maybe around 15 to 20 players, which was not the case. So which means standardization becomes a problem, the definition of the interface is there. And then with these multiple players, the time to market also increases. But at the same time, what's the demand from the industry? The demand from the industry is that we need to have a very short turnaround time for the production. Last but not the least, safety and security. Defects can be life-threatening, so this is something which we can't take any chance on in the automotive industry. So, multiple challenges. So one is, I would say, the ambitious, high complex projects with a very short turnaround time, as well as looking at safety and security which is critical. So a lot of front loading is required, and that is where some applications like organizations from Altair is really helping us for the simulation. So simulation is a big thing that we are using for co-development with the customer and also to have a faster development time inside the organization. Second thing is due to this kind of a multiple sensors, multiple components and electronics that is getting added, the signal flow and the control algorithms are becoming much more complex and also a complex architecture. So which means that the verification and validation challenges are very, very high, much more higher. I would say that it has become 5 to 10 times if you look at in the last decade itself. So the third one is everybody is wanting everything as a lesser price. So it is always a challenge to look between this growing complexity versus how do we have a boosted productivity. A huge challenge, I would say. right? And next one is there is also a migration towards centralized e-architecture, so which means that the current architecture, the current systems that we have, we kind of need to look at it. So reusable, scalable, value-added platforms are something which we are looking at in the industry. And there are chances that these horizontal technology stacked could actually replace the vertically integrated embedded system. So which means that architecture and the way we look at developing the software itself needs a massive change. And last but not the least, a whole lot of collaboration. So this is an era of, I would say, competition. It is competition and cooperation together, and it's an era of co-creation. So there is no OEM or no supplier or no tool maker can do anything standalone. But I think this is an industry where everybody has to collaborate if we have to look at the time to market and also make start developing products together. It's not that you have a clear requirement specification and then we deliver. It has changed. So agile is the way. Front loading, because we cannot afford to have any kind of defects which are unearthed towards the end of the life cycle. Front loading. And very important is also to have the simulation in terms of the development efficiency as well as the product performance. So simulation is also used in a big way. And change of architecture. The current way, this is another problem statement we have, because you have this legacy code which is sitting in and a lot of outdated electronics which is in the vehicle. So change of architecture is something which we need to look at, and this is and with all these HPCs, the zone computers and other things, this is also being kind of relooked. So modularity, scalability, it is there. Modular hardware for reusability as well as reduced complexity is what is the industry looking at. And use of AI ML in everything, in everything in the value chain, whether it is product or process, we need to actually have it done. And last but not the least, we are also looking at more standardization, because when we are talking about I would say, multi-party development which is happening, standardization is the key, otherwise you lose a lot of effort. And the development efficiency, what we are talking about, doesn't come to picture. So there are multiple use cases that we use Altair in Continental. So one of the use cases which I would like to bring about, because for us safety is very, very important, and Continental as an organization, we are talking about zero accidents is what we are talking about in the future. So one of the things which we use the Altair is the Altair radios V2019, which is used to solve certain issues which are related to the crash detection. So this is one of the things which are there, and we have found different benefits of using this topic, which is like, for example, in airbag deployment and many other things, we have found high efficiency by using the Altair tool. So this is one of the examples, but you can see that many of the areas which I talked about in terms of simulation, front loading, co-development, co-creation, we work close together with Altair in a big way. So just to summarize what's happening in the mobility industry, so EXE, it is focusing on the requirement of the customer, which is user experience, security and safety. This is the most important thing. Second one, digitization and connectivity is here to stay, and it is costing the most comprehensive transformation what we have in the automotive world, and I think 5G coming will also be a big game changer for us. Software is the heart of mobility at this point of time, and this also will have major transformations which is happening in the next decade, I would say. Automotive industry will have to accelerate the adoption of AI, data, 5G, cybersecurity and cloud, and all these technologies will coexist together. Software architecture and the development methods have to go under massive transformation, which is looking at the legacy code as well as integrating the modern HPCs into that. And last but not the least, I would say co-creation through collaboration is inevitable, and that's where the mobility industry is headed to. So thank you very much. So that is what I just wanted to share on what's happening on the mobility front. Thanks a lot. Thanks, Altair, for this opportunity. Yeah.
Thank you, Lata, for such an informative and insightful presentation. Now, I would request Dr. Jordi Solikasny, the Vice President of Global Business Development for Electromagnetics and Electronics, to felicitate Ms. Lata with a memento.
We're going to continue with our fourth session on next-gen designs through AI, ML, and VR applications in rail transportation by Mr. Yogesh Kumar, the Vice President of Technology and India Engineering and Wabtec Corporation. Mr. Kumar and his team lead the design, development, and commissioning of locomotives around the globe. Several locomotive programs in various geographies, including India, United States, EMEA, and ASEAN region, have been executed by his team. His responsibilities include building global capacity and capabilities in India for multiple technological domains, including mechanical, electrical, and electronics, software engine, and data analytics. Yogesh is a certified Six Sigma Black Belt. He considers himself to be fortunate to receive GE India's prestigious Pillar Award for Operational Excellence from former President late Dr. APJ Abdul Kalam. Yogesh is also a recipient of GE's Edison Pioneer Award. Yogesh holds a master's degree in mechanical engineering from Gannon University, Pennsylvania, and a bachelor's degree from NIT Trichy in production engineering. Over to you, Mr. Yogesh.
Thank you for that kind introduction. Lata ma'am, thank you for setting such a great context, and I can relate to the challenges you are facing in the automotive world. I'll talk about rail technology, and my topic is, you can see, next-gen designs using AI, ML, and virtual reality. So let me share one story. I had this fascination with AI, ML, even when I knew about something like this exists. I was growing up as a child in suburbs of UP, and I used to take the public transport to my school. And most of us can relate to the story that the bus had very inconsistent timing. And I used to wonder if there was a system which could predict and tell me that when the bus is coming, I don't have to waste time standing at the bus stop. Look where we are. We don't even consider that AI and ML example when we track the bus in the GPS, or when we look at when can we reach to the destination when we are looking at the Google map. So that's where we have come. So it is here for us to harness. It is here for us to make a choice how much we deploy and to what extent and scale we deploy today. Little bit about the center where I come from. I am from WITEC. We call Wabtec India Technology and Engineering Center. This has got 1,200 people. Nothing close to Lata ma'am was talking about. They have 4,700 engineers. But I'll say these 1,200 engineers today are developing technology not only for the rail in India, but for the globe. They are working on digital, electronics, freight equipment, transit solutions, deploying multiple software controls, mechanical fusion technologies. If you go to the next page, so I wanted to share a little bit about WebTech. Many of us might not know WebTech Air Brake Technology Corporation. We are boasting our legacy into three great giants of this century. We had George Westinghouse, we had Thomas Alva Edison, and Louis Fevele. Westinghouse, many of you would have read in the textbooks, he was a big proponent of AC technology. Nikola Tesla, Timoshenko actually worked alongside Westinghouse in WebTech. Thomas Alva Edison, I'm sure he doesn't need any introduction, brought the light bulb, but he also brought the DC current and applications to the world, and many more technologies. Louis Fevele, he brought the pantograph, the electric heater, many electromechanical components. The reason I'm sharing this is we boast the legacy into innovation. We are deep entrenched into innovation company. We carry that legacy forward. We carry that legacy forward with responsibility to the sustainability. So, I wanted to share a little bit about what these sustainability pillars today we are having to take this legacy forward. The first one is innovating with a purpose. When I say innovating with a purpose, that's with the purpose of minimizing the impact on the planet. I wanted to share today one personal experience which I'm going through in the company. We have two businesses. We have transit and freight. Transit is looking at how can we reduce the dust which comes out of the friction pads. Can we make them dust free? We have the heat, ventilation, air conditioning systems where we are looking at can we deploy the technology where the microorganism can completely be filtered, because the hygiene has taken altogether a new dimension post-COVID era. We are looking at the next gen technology in the braking systems. One of our Metroflex solution which we are deploying in Europe is an industry benchmark. We are looking at solving unique problems in a market like India. You have seen these double deck containers. Now when you have double deck container, that means your overhead electric lines goes up, and you are looking at much high reach pantograph than usually is deployed in the developed world. So we are developing very, very diverse products to address the different challenges of the industry. When I look at the freight industry, today decarbonization, I'm sure all of us know decarbonization is a big initiative for the transportation industry. We are looking at how do we get rid of carbon. Our customers have committed to the sustainability goals. We are looking at burning hydrogen in the internal combustion engines. We are looking at deploying hydrogen in the fuel cells to propel the locomotives. We are looking at batteries. We are looking at automation in the locomotives. We are looking at multiple digital and electronics technology to deploy and to reduce the carbon footprint on the planet. I wanted to share, in a locomotive there are 20,000 parts. And if you thought that the Tesla car has got the most complex software code, let me remind you, a locomotive has 5 times more coding to be done to make it safe for the operators. If I look at the other sustainability pillar, driving responsible operations, so we are looking at using the resources more prudently, optimizing and making the use of the resources only on the need to know basis and how much to use. And then, of course, we are empowering our people and communities. We are engaging with the communities to address their specific needs. Little bit about WebTech in India. We call ourselves a mini WebTech in India. We have got operations footprint across India. So if I look at, I come from Center of Excellence, we call YTech in Bangalore. We have got a very small center in Hyderabad. We make the locomotives in factory Bihar. This is where we are making 100 locomotives every year for Indian Railways. We have got our transit business, which produces air brakes, compressors, and all of that in Tamil Nadu, here in Hosur, right next to Bangalore. And then we have multiple other locations for different components as well as services in India. I am very proud to say that we are a very strategic partner to Indian Railways to continue the mission of Make in India and propel that further to lead into the decarbonization era with the Indian Railways. We have got 14,000 LHB coaches, 3,500 metro coaches, 3,000 electric locomotives where our components today are deployed. And then we have also delivered 430 plus diesel electric locomotives to Indian Railways as part of contract for the 1,000 locomotives which we had won in 2016. So a little bit about what we are doing for India in the rail space. This is a locomotive which we delivered in 2018 to Indian Railways. We have two versions of this locomotive. We have a broad gauge locomotive. This is WDG4 and WDG6. These are 4,500 horsepower and 6,000 horsepower locomotives. The nomenclature there, WDG4G, is really wide gauge. It's for goods, 4,500 or 6,000 horsepower, diesel, and then GE. We were part of GE as GE Transportation, and 2019 is when GE Transportation merged with WebTech. So we still carry the name of WDG4G. This locomotive has set many benchmarks in the industry. I wanted to talk about few. I'm sure you will all be very proud of the first rail or first train which touched the Manipur a couple of years back, around a year back. That train was hauled by our own locomotive. This was because it is a difficult terrain, so Indian Railways chose to have our locomotive to haul the train. We also have I'm sure you would have heard Python train. Python train is being hauled by our locomotive. This is a double deck container train. And we have also had the additive. We are deploying additive technology to expedite the manufacturing for some of the specific components for this locomotive. We are deploying the mixed reality along with the AI and ML tools to develop not only the locomotives or technology for India, but for the globe from India. I just wanted to share a few examples where our team is today looking at how can we develop the zero carbon hydrogen locomotive. The team sitting in India is looking at what fuel cell technology or a battery technology works best for international as well as so when I say international, it is in our context, it is minus North America. So we are looking at North America as well as the non-North American market, what solutions work. We are also looking at the pure battery technology, and I'll talk a little bit about that. So what's the secret sauce behind all of this development? I wanted to just little bit latch on to what Lata ma'am was talking about. The world today is very different from how people used to buy car or how people used to buy locomotives. They earlier only talked about the performance, they talked about the reliability, and that was it. And then rest of it was left to us. Today, I'll talk about three P's, right? It's about the product. So product expectations don't change. That means you have to give performance, reliability, availability. The second P is really about the predictability or productivity. They want these machines to be predictable. They want these machines to be productive. They want to minimize the downtime, whether it is in a yard. So in the locomotive world, when you look at the yard is a very, very complex infrastructure to maintain. You will be surprised, there are locomotives which get lost in yard, and there are containers which get lost in the yard. So our customers are looking at how do we navigate through the yard in the minimum possible time. When you have a locomotive, they are looking at, hey, I don't want the locomotive to be sitting in the maintenance shed for a longer duration. Can you tell me what's going to go wrong with my locomotive? And I can then plan bringing the locomotive to the maintenance shed and repair it and then take it back to the field. So predictability is a big expectation there. And the third piece I'll talk about, their preferences or practices. They want the state-of-art product, they want the predictability, at the same time they don't want to change their complete infrastructure. They still want to continue with some of the practices or infrastructure they have got. Now imagine when you have the complexity of delivering a zero carbon locomotive, delivering altogether a new technology, and still optimize with the practices or infrastructure your customer has got. I think you have no choice. You have no choice than to deploy the tools which were never deployed before. And that's when I bring, of course, the domain is a core engineering. We continue to develop. We have the deep domain experts. We have the system integration. I think that's what we are great at. And now we are bringing the other dimension, which is AI, ML based predictability or data analytics or simulations. One thing which I have realized is while we are developing ML in our models, we are deploying data analytics or artificial intelligence. One area where we are still continuously learning, and we call them as reinforced learnings or reinforcement learning, machine learning algorithms. We are still continuously learning because there are a lot of things where human beings, we answer that as, hey, what do you think it will take? So somebody asks, how long will you take from point A to point B? And our answer is, it depends. Now, how do you teach machines? It depends. It's very difficult. I call that, how do you train a dog, right? A good dog and bad dog. You look at the behavior of a dog, and if it is doing the right things, you say good dog, right? And then the dog learns. That's how we are trying to teach our machines. So that's the reinforced machine learning algorithm we are applying, where we are saying, hey, this trip was good trip. This was not a good trip. So when you accumulate lot of good trip or lot of good behavior, then at some point your machine starts to recognize what is good for the customer or operator. Few examples from our India locomotive. So in this page you see, when we were developing India locomotive, we leveraged the multiple predictive analytical tools. We had the operator cab you see there. It's very critical for the operator to have the comfort when they are piloting the loco. We had multiple structural tools, and we are thankful to Altair. We deploy many of their tools in doing this. We had dynamics analysis. Now, when we are doing all of these analysis, I think these are still the tools which we have been using for at least last decade. But what we are doing different is we have terabytes of validation data, which we have taken in the lab. We have 30,000 locomotives out there. We have collected a lot of data, validation data in our lab and in our field. We are trying to make sense of this data. We are coupling that data with our analytical tools, validating on the go, validating our models on the go, and making the right decisions for our designs. This is virtual reality. We have got our manufacturing teams, design teams, and field services teams, because like Lata ma'am said, there are no single industries, right? There are no single companies today who can deliver the expectations of any customer. It's the same thing in the companies too. One function cannot deliver the expectations. So we are coordinating with the use of virtual reality with manufacturing and field services. One of the things which we have realized, when you are working upfront with the manufacturing friends, when you are working upfront with the services teams, and they can virtually experience and build the product, your rework is much less. Your services folks are trained upfront on the new product technology. This is a map. We are deploying the remote monitoring and diagnostics field solution for Indian Railways. And I'm giving you Indian Railways example, but around the globe, we use a similar technology for all our other customers. So here you see those blocks on the map. You have red, green, and yellow. Green means the locomotive is healthy. We have the algorithm which is capturing the data from the locomotive live, real time, and they are predicting whether the loco is healthy. If there is something wrong potentially which will happen in future, then we are asking the customer or operator that, hey, you probably have to do 1, 2, 3, or you might have to take the locomotive to the maintenance shed based on the severity of the issue. The red ones are really about to fail, and we really need, we call RX, right? When you go to a doctor, there is a prescription and they write RX. We issue the RXs to the operator that, hey, here are 2 things you got to do to continue your mission. So this is being done live with our center in Rosa for Indian Railways, all the Indian Railways locomotives which are supplied by us. So this is a summary of how we are doing it. We collect the data, we are applying the monitoring and diagnostics algorithms, we have a lot of predictive algorithms, and finally we are trying to make a decision on behalf of customer and our operators to minimize their downtime and to maximize or optimize the asset productivity. This is another example of a digital twin. So what we have done, our engine, so we classify our locomotive with the vital organs, because vital organs are critical for us to operate in a locomotive to complete a mission. One of the vital organ is engine. And what we have done, we have physics-based model, and then we have statistically looked at the data, what works and what is healthy and what is not healthy. And then we are deploying this algorithm, this complete algorithm in our remote monitoring and diagnostics strategy. So the engine health is continuously monitored, because engine is one of the critical pieces to complete the mission. And we have been very successful. We are delivering the world-class performance, reliability, and availability. At the risk of bragging, I'll still say that the train which went to Manipur, there was a certain amount of confidence in our locomotive. So that's why I say that the AI and ML we have deployed on our locomotive is optimizing the performance, is addressing the expectations our customers have had. This is our next gen locomotive, and we call the future is here. We delivered the first battery electric locomotive in the world in 2020. 2020, we had delivered the first battery electric locomotive which had 2.4 megawatt hour of power on board. This was tested in California, and to our surprise, the locomotive performed exactly the way we had predicted, thanks to our analytics and machine learning and AI. We are now on our mission to develop 8 megawatt hour locomotive. We are deploying the lithium ion batteries in this, and we already have secured several orders. Now, when you have a battery electric locomotive, you have multi-physics to deal with. And what's happening now, the expectations in the delivery times are coming down and your complexity is getting multiplied. So what we are doing here, we have the electromagnetic models going on, we have thermomechanical models, we are doing CFD, structural, predictive models. There is a multi-physics environment we have set up for predicting the performance of this locomotive, not only in terms of the haulage ability, but also in terms of durability. We do not have time today, the liberty which we used to have earlier in terms of validating. You can't have all the 9 yards of validation. So we are doing that, and I'm very happy to share that we'll be delivering our first 7 megawatt hour locomotive in Australia end of next year. This is just a summary that we are deploying a lot of innovation and multi-physics driven strategy in our product development. So we are following the build, expand and grow model, and several examples here. I'll little bit maybe talk about the automation. So automation in locomotive world, rail world is real today. And we are the ones who had deployed the PTC in North America. PTC is a safety solution. It does a lot of, so it can predict if there is a collision going to happen, or if the locomotive is operating with the healthy parameters, or the locomotive is going to get stuck in the yard. So that solution, now we are expanding it to the automation, and I'm sure automotive world is going to go through the automation, so is locomotive. So I'll conclude my presentation by saying that the product development transformation, it is the driving force for people like Altair to develop next gen tools. AI, ML, data science which can meet the customer's expectations, I think they'll sell more. So thank you for patient listening. I want to conclude with that the future will decide, so the scale of deployment of AI and ML will decide whether the companies will persevere or perish. Thank you very much.
Thank you for such an interesting presentation, Yogesh. As a token of appreciation for your valuable contribution, may I now call upon Dr. Camilla Flider, the Director of Material Information at Altair, to kindly present a memento to Mr. Yogesh Kumar.
Now, we have Dr. Camilla Flider, the Director of Material Information at Altair, to present on enabling informed material application for sustainable high-performing products.
For a kind introduction. Good morning, or good afternoon already, everyone. I'm delighted to be here today. It's very refreshing to meet in person after a long break. My name is Camilla Flider. I come originally from Czech Republic, and I work at Altair in Germany since 8 years now. Since I'm at Altair, I went through different roles, and today I am glad to be part of the Material Information team. In my today's presentation, I will be talking about Altair's solutions, enabling informed material application for sustainable high-performing products. Sustainability, a megatrend which is driving industry and society. One of my contacts shared a story recently on LinkedIn which reminded me on my own childhood. I grew up at a farm and we produced our food ourselves. The rest went on compost and were reused in the garden. This is what I realized years later is nowadays called circular economy. Today, we live in a new era. We live in megacities. Our lifestyle evolved since then. Our lifestyle leaves a footprint on planet which needs to be protected for the generations to come. Today, one of the topics I will be talking about is climate protection, and more particularly, CO2 footprint reduction. Not only our lifestyle evolved tremendously, but also science and technology, offering endless possibilities. A new perspective on materials and their usage to minimize the environmental impact raises across industries. We live in an era of paradigm shift, which brings challenges as well as new opportunities. Digitalization is a powerful tool to connect the dots and enable groundbreaking innovative solutions. So let's have a look on how Altair is connecting the dots over the digitalization. The sound, please. There is a video with a sound. Yeah?
Sustainability is transforming business practices across the globe as companies today face a vital design imperative: quantifying and minimizing their carbon footprint through digital innovation. Thanks to Altair's world-class digital technologies and engineering expertise, we empower companies around the globe to make better material decisions, optimize product designs, and adopt organization-wide processes that add value and reduce costs at every stage of development. Together, we can help organizations choose the right material, the right design, and the right process to develop solutions that minimize carbon emissions and bolster your bottom line.
Sustainability and climate protection through digitalization. Everything starts with a material selection. In 2020, Altair acquired Embase, and with it, most comprehensive polymer database, as well as software for material information management. And additionally to that, very important, over 3 decades of engineering know-how. Altair took over as well the role of coordinator and software provider for the Campus Plastics Consortium. Campus is grouping the world-leading material manufacturers, and through this platform, they are giving at disposal material data, and this is important. This data is comparable. So we had a great basis to realize our vision, to create a smart, flexible material information system which is implemented in a global cloud platform, which enables material selection from one data source, computer-aided multiphysics simulation, and CO2 footprint reduction.
The right material is the one that performs best in both the manufacturing process and the finished product, while having the smallest possible carbon impact. Altair's material database helps purchasers, engineers, and analysts across the organization collaborate and make decisions from a single data source. With it, they can understand global availability, supplier options, and the environmental impact of material choices. Additionally, our material database enables users to discover material behaviors for predictive modeling and can predict untested materials through integrated AI. Altair's connections with material producers are second to none. And our integration with Embase means that our database is built upon the world's most comprehensive polymer database.
We want to shift material information system to a next level. For that, it is important for us to have partners such as Motan. To give you a little bit of context, Motan is a leader in periphery equipment and material handling in the process, such as mixing, dosing, and drying. Motan has a hardware, software, and the know-how to track the CO2 throughout the whole material handling process and to get real data, which then will be available in Altair Material Data Center. So this project is really unique, and it's a first approach for such kind of integration in the industry. Motan will be as well presenting a demonstrator, this demonstrator, at K 2022. This is the biggest plastics trade show in the world, which will take place in Düsseldorf in Germany on October 19 to 26. So what was the challenge of this project? Real CO2 footprint information is too limited to make correct assessments and informed decisions. CO2 footprint added during the process is key, but often not available. And one has to make estimations based on literature, which is the only option. So our solution is to quantify the material and process CO2 data during the entire material handling process. The value which we are bringing to customers is a holistic CO2 footprint data which allows informed material selection and design decisions that leads to carbon footprint reduction.
The right design is a delicate balance of performance, manufacturability, and cost. Altair's industry-leading suite of simulation, machine learning, and data analytics tools, combined with our decades of engineering expertise, empower product developers to achieve designs that maximize materials potential while minimizing risk and reducing waste. From optimization tools that drive minimum mass designs to manufacturing simulation, multi-scale modeling, and more, Altair solutions make material substitution smarter.
So this is the next step when we had selected the material. So we had CO2 information, and we want to engineer or re-engineer something. So the next step is the simulation, because Altair Material Data Center provides as well material data ready to use for simulation. So I spoke already about material data availability through the Material Data Center. Another part of this comprehensive value chain are solutions for virtual material testing. I mean, for example, new material development or raw test data processing through, as I told previously, ready-to-use CAE cards for simulation. The part of the portfolio, as shown in the video, are the solutions for components optimization and sustainable product design. Altair is offering as well tools for manufacturing process simulation and its optimization to obtain the required quality at the best manufacturing costs. Of course, well, the core of our competence is the simulation and product validation through integrated simulation. Altair has all necessary building blocks to build digital twins. We are working closely with our customers to address their specific challenges. So it is an iterative process to address all possible use cases you might have, because nowadays practically everything is possible to be simulated, and then a digital twin can be created. So the power of Altair simulation is its consolidated open architecture platform under one license. Additionally, Altair is empowering its partners and customers through a world-class engineering team, and it's a very committed community. In addition, this was mentioned here previously already today, is the Altair Partner Alliance program, which enables to access third-party solutions to complement Altair's portfolio. As here I am talking a little bit more today about plastics application to show you the whole process, which is applicable to any other types of materials at the end. We have very strong partners for plastics-related topics. I would like to share with you some successes from our customers. Material substitution. This is really a typical case where we can help a lot. Here, it's going about replacing metal by plastic to obtain a more lighter and more sustainable product at a lower production cost. So this was an application for railway as well, where it was important that this component lifespan is 30 years, so which was achieved. And at the same time, the weight of this component was reduced of 25%, and its cost then of even 35%. Victor Seresov, the CEO of X Plus, is telling that Altair's complete engineering and CAE workflows for lightweight design and material substitution enable sustainable design. Circle product development at Alpla. So the challenge was to simulate and automate the virtual development process, which enables to create a new product category, which is made from 100% recycled material, which itself is then 100% recyclable. Oliver Unterlechner tells that the simulation was here really key enabler for this 100% circular packaging system. So here you can see part of the process where the simulation was used for the simulation of the manufacturing process, packaging, and the drop test simulation. The next one I would like to talk about is Sika, where topology optimization was used to make vehicles lighter and greener. So trust me, Altair is really the leader in topology optimization. We are enabling our customers since more than 30 years with topology optimization to use in the best way material. And this enabled to save a lot of tons CO2. Stefan Niggemann, expert structural systems from Sika, tells that, well, they follow the motto, reduce is better than recycle, and that's what I think as well. Topology optimization is not only applicable for plastic components, of course. It can be used as well for metal components optimization. Here an example on a very large component for railway application at Transant. Transant is a joint venture with OVB Rail Cargo and Westalpe Stahl GmbH. So the challenge in railway is the world certification process, which here could have been ensured by simulation. And this process enabled to create a more lightweight design which was more efficient to manufacture. So very important, as the previous speaker told, there are a lot of parts in a locomotive or in a railway. So here the number of parts to assemble was reduced of 40% and the weight of 20%. On the top of that, 4 tons of payload were gained. So I'm coming back now to Altair Digital Twin, about which I spoke about previously. As I told, Altair has all the building blocks to create digital twins in close cooperation with you. And in order to real-time monitor processes, to optimize them, and to reduce the downtime. I would like to now share with you a sneak preview of Altair's proposal of a digital twin.
The right process is one that maximizes cycle speeds and improves yields, all while safeguarding complex molds. Altair's digital twin software optimizes the manufacturing process at every step, from injection molding simulation, part and tool interaction, to structure and fatigue analysis for robust processes. Our comprehensive workflows help manufacturers produce better products at a greater scale, with less machine downtime. Altair's digital solutions facilitate end-to-end strategic thinking and connect siloed data sources to streamline decision-making, helping manufacturers keep sustainability at the forefront. Our materials data, digital infrastructure, and simulation-driven design tools improve products and safeguard tools.
Will be there. Visit us at our booth. What I would like you to remember today is that Altair is building flexible and smart material information system, which is integrated in a global cloud platform, and which will be connected directly as well across our portfolio with our other tools, as my colleague Michael presented previously as well, with modeling and visualization tools directly. I would like to tell you as well that you can access data we have in our database, but it is possible that we give you your own private space where you can consolidate and manage your data. Our engineering team can accompany you creating this structure. It is very flexible, and I believe that this can empower you and your teams with data, which then you can use across different applications, because you can export them directly for simulation. In case you would be interested as well to share your data externally, as for example, you are a material producer, it is possible that our team provides you with a solution to have an external system where you expose the data of your choice on internet for your potential customers. Thank you. That's everything from me today.
Thank you, Dr. Flitter, for such an enlightening session. Now, I would like to invite Dr. Jody Solar-Castany, the Vice President of Global Business Development, Electromagnetic and Electronic Solutions at Altair, to present on the topic End-to-End Electronic System Design. Over to you, Jody.
Hello everybody. And it's a pleasure to be back in India for this in-person Altair Technology Conference. This time to talk about electronic system design from an end-to-end perspective. And basically, when we look at what we do and how we are helping customers, there are two words, smart and connected, that basically imply more electronics. So basically, if you look at a lot of the verticals, you see that electronics is growing almost everywhere, on consumer electronics, on automotives, and many more. And this is an area where Altair, we have been investing significantly with internal developments and also with acquisitions. If you look at the last 10 years, So we have acquired technologies related to antenna simulation, wave propagation modeling, circuit simulation, enterprise computing, thermal simulation, and also some other acquisitions that I will explain a bit later today. And just for you to see how some of these technologies are used in the development of a product, we have a short video that we think you would like to see. As a summary of the video, basically with the solutions we have for electronic system design, you can have different types of engineers working on smart and connected products. And if you go from left to right, we are talking about PCB development, wireless connectivity, mechanical and thermal, mechatronics, circuit simulation, embedded software. Some of these technologies are HPC enabled, available in the cloud or locally on demand, and you can have all these technologies under one license thanks to the Altair units. And this is especially useful when you look at the challenges you have when designing electronic products. You have here a printed circuit board. We have with 5G, we have higher speeds, means more interferences. Also, you need to place the antennas on the device, thermal effects, which are very important, manufacturability, enclosure materials, and others. And also, there is another important aspect, which is in the past, this type of, or the electronics developments could be done with an electrical, a layout, and a manufacturing engineer. But now the electronic systems are more complex, and you need a bigger and more multidisciplinary team to address these developments. And one of the challenges is that we are seeing